In this video, we're going to look at using Venn diagrams to solve problems. If you're looking for a video on set notation and probability, please check out my site, as this is just a problem solving video. Let's start off with interpreting Venn diagrams. So in question 1, we're told the Venn diagram below shows information about the food people ate at a school one day. So we can see we've got a box and we have two ellipses that intersect. What we're going to do is look at reading this Venn diagram and understanding what each section means. We've got chips and we've got pizza. The best place to start is outside of those two ellipses. This here, this number 11, represents the people who didn't eat chips or pizza. So these are the people that did neither chips nor pizza. Let's now go to the middle. We call this the intersection. This number 4 represents the people who had both chips and pizza. This part right here with the 12 in is the part that represents the people who had chips only. This part here with the 6 in it represents the people who had pizza only. So if we look at this now, what we've got is the ellipse. This is the ellipse representing the people who ate chips. We can see that there are 16 people that ate chips. Often students say there are 12. 12 only ate chips. 4 ate chips and pizza, so 16 ate chips. If we now look at this ellipse, these are the people who ate pizza. We can see that 6 people ate pizza only and 4 people had both chips and pizza. That means that 10 people ate pizza. The answer isn't 6. 6 represents the people who only ate pizza. So, let's go ahead and answer these questions. Write down how many people ate chips. Well, the ellipse that holds chips is right here. 12 plus 4 is going to give us 16. So all we need to do is write 16. In part B, we need to write down how many people ate only chips. Part A will help us. Only chips is going to be 12. In part C, write down how many people ate only pizza. Well, only pizza is this part right here. So if we look at that part right there, we can see that that is going to be the 6. So we write 6 just here. What does the number 4 represent in the diagram? It represents the people who had both chips and pizza. So with the intersection, it's and. And then finally, what does the number 11 represent in the diagram? It's the people who had neither chips nor pizza. So nice and straightforward, nice and logical. In question 2, we're told there are 54 students in a school. The Venn diagram below shows information about the subjects they take. We've got maths and we've got English. We've got 6 people who do maths only, 25 who do both maths and English, and 8 people who do English only. We're asked to complete the Venn diagram. The only thing missing are the people that do neither maths nor English. We know there are 54 in total, so if I go ahead and add these 3 values here, 31, 39, 39 from 54 gives me 15, so 15 people go on the outside, and they're the people who did neither. We're asked to state how many more students take English than take maths. A couple of ways we can do this. The easiest way to do it is simply consider the 8 and the 6 and write our answer as 2. So that's one way of looking at it. The other way is to add all of this up. 31 did maths. We can see that 33 did English. So again, there's 2 differences. But essentially what we're doing is only adding the 25 to then subtract it. Part C. Peter says 8 people chose English. Explain why he is wrong. 8 people chose English only. The actual answer of how many people chose English is 33, as we have the entire ellipse to consider. So if he had said 8 people chose English only, that's perfectly fine. But 33 people chose English in total. In question 3, 45 children were asked about the sports they played. Some information is shown in the Venn diagram below. We're asked to complete the Venn diagram. With these particular Venn diagrams, where we have 2 ellipses, we should have 4 numbers. 1 in this part only, 1 in the intersection, that's the middle, 1 in this part only, and 1 outside. We can do a Venn diagram with 3 ellipses in it. I think that's beyond the sort of scope of this video, but you can certainly do that. So let's have a look. We've got 45. Now, if I add these together, that's going to give me 32. 32 plus 9 is 41. 41 from 45 is going to give me 4. So complete the Venn diagram. Football only is 4. Football is 18. 14 is both football and tennis. We've got 32 doing tennis and 18 doing tennis only. 9 outside represents those that played neither football nor tennis. So how many children played football? Again, students want to write 4. The answer is 18. 4 plus 14. How many children didn't play tennis? A few different ways that you could do this. The easiest way is to simply consider the area that we're interested in. So if I think about this now, and I'll just go ahead and do this, the ones that play tennis are going to be inside this particular green ellipse. So we can see the ones that didn't were the 4 and the 9. So everything in the part just here that I'm shading is what we're looking for. In the more advanced video on set notation and a bit on probability, you will look at these particular regions in terms of shading. But all we're looking at are now the 4 and the 9. These are the children that played neither, and these are the children that played football only. Therefore, those that didn't play tennis, we simply add those together. Alternatively, you could have added the 14 and 18 and taken it from the 45. I think it's nicer to do it this particular way by considering which is not rather than which is. Okay, what we're now going to do is move on to looking at setting up the Venn diagram to solve wordy questions. The first 3 questions are going to be the easier sort, and that's where we're not finding the intersection. So let's go ahead. In task 2, these are the non-intersection questions, and in question 1, we're told 45 people go to a party. 22 people take Coke, 14 take lemonade, and 10 take both Coke and lemonade. In part A, we're asked to draw a Venn diagram to represent the information. So let's go ahead and draw our Venn diagram. So we have our box. Make sure you're putting a box on. Again, students seem to like missing the box out. So here are our 2 ellipses. Doesn't have to be immaculate, just gives us some idea of what's going on. So at this point, what we're going to do is put on here Coke and lemonade. So Coke is here and we've got lemonade there. Doesn't matter which way around you put them, that's perfectly fine. Okay, let's just be careful here. We've got 45 people, 22 people take Coke, 14 take lemonade, and 10 take both Coke and lemonade. I'm going to start with the 10. The 10 goes in the middle. We're told 22 people take Coke. The big error here is people want to write 22 in here. That's not correct. We've already got 10 of them here, so we only need 12. Just consider this total ellipse must sum to 22. Coke is 22. If I put 22 in there, we'd have 32. So it's just 12. 14 take lemonade. Well, I've already got 10 here, so lemonade only is 4. Let's just read this. Coke only is 12. Coke and lemonade is 10. Lemonade only is 4. we need to finish this. Remember, with the Venn diagram, we need 3 different values. I'm missing this one just here, and these are the people that take neither. So we've got 45. If I add that, that gives me 22. That gives me 26. 26 from 45 will give me 19. Part B, find the number of people that take neither Coke nor lemonade. Well, that answer is 19. Find the number of people who only take Coke. Coke only is the 12. Lemonade only is the 4, and the 10 is the people that take both. So find the number of people who take only Coke or only take Coke. The answer is 12. Right, let's have a go at the next one. At a school, some students study maths and English. 6 students study both subjects. 14 study maths and 19 study neither subject. Given that there are 48 students in the school, A, find how many study English. B, find the probability that if one student is chosen from random, they only study maths. Or chosen at random, I think would be better English. So let's go ahead and draw a Venn diagram. So it's slightly less structure to this question, as we're not told to draw a Venn diagram. We don't have to use a Venn diagram, but it's going to be quite easy if we do. So what I'm going to have are my 2 ellipses, and we're going to label these up now, maths and English. It's entirely up to you on which one you want to call which. I've got no preference. I generally read it as the question goes. Could do it alphabetically, entirely up to you. So let's do maths. So maths is just here, and let's put English just here. Making sure we have now the box on the outside, as that is what we call the universal set. So all numbers will fit somewhere in one of these sets. So let's have a look at this. 6 students study both subjects. 6 is going in the middle. So on both of these questions so far, we've been given the intersection. These questions are slightly easier than actually having to find the intersection, and we'll look at that shortly. Okay, 14 students study maths. So I need to fill this out. Got 6 here. Well, 14 is going to give us now 8. 14 minus 6 is 8. So if we just look now, I'm not going to put 14 in here. If I put 14 in there, it tells me that 20 are studying maths. 19 study neither subject. So 19 is on the outside. What we need to do is complete this given there are 48 students. So all I need is English only. Well, there's my 14. That's 33 added together. So that looks like this is going to be 15. So let's check that adds up to 48. 14, 29, 48. So in part A, we need to find how many study English. The answer is not 15, it's 21, because we've got 6 who do maths and English and 15 who do English only. In part B, we're asked to find the probability that if one student is chosen from random, they only study maths. Maths only is this part right here. So we have 8 of those out of our 48 students. 8 over 48. We could, of course, simplify this and write this as 1 over 6. But maths only, the probability that if one student was chosen at random, they study maths only. Well, there's 8 students who do that out of 48. Okay, question 3. A survey was conducted about people owning hats and scarves. 14 people owned only a scarf, 2 owned both, and 12 owned a hat. Given that 56 people were surveyed, A, draw a Venn diagram to represent the information. B, find the number of people who own neither item of clothing. C, state how many more people owned scarves than owned hats. And D, find the probability that if one person was chosen at random, they would own a hat but not a scarf. Most problems with Venn diagrams is reading it. It's not actually the maths, it's reading what we're being asked to do. So do take your time and simply think, is that what I'm being asked? Often the mistakes that we find are just misreading the questions. So let's go ahead and put our Venn diagram together. So what we've got then is hats, so let's put that just here. So we've got hats and we've got here scarves. Scarves, there we go. So hats and scarves. So we've got now 14 people owned only a scarf. So that needs to go there. Just be careful. It isn't 14 people owned a scarf, only a scarf. 2 owned both. That goes in the middle. 12 owned a hat. Well, if 12 owned a hat, 2 of them already here, so the other 10 must go there. Just run your finger around there and say, does that equal 12? Yes, it does. 2 in the middle, 10 in hat only. 56 people surveyed. Well, we're now up to 26. So 10 and 2 is 12, plus 14 is 26. So 30 must go on the outside. 30 represents the number of people who had neither a hat nor a scarf. So there's our Venn diagram. So we need to now find the number of people who own neither item of clothing. Just done that, that's 30. They're on the outside. Part C, state how many more people own scarves than owned hats. Well, we can just look here. It's going to be 4. We've got 14 and 10, or if you like, we've got 16 and 12. Doesn't really matter. By adding and subtracting this 2, we can see that the difference, remember these are the people that are both, so they're being counted in hats and scarves, so it's just the difference between these 2. In the same way, the difference between the English and the maths is 7, because you're going to add the 6 only to take it away. And then in part D, we're asked to find the probability that if one person was chosen at random, they would own a hat but not a scarf. So that is hat only. So hat only is going to be 10, and we've got a total of 56. You can, of course, simplify that if you want. With probability, you generally don't. 5 over 28 is fine. So hat only. Hat but not a scarf is hat only. Don't fall into a trap now of writing it's 12. So there we go. They are what I would call the non-intersection questions, where we don't have to find this intersection. Let's move on and look at task 3. So these ones are slightly harder because we need to find the intersection. We can do this algebraically. I just think it's easier at this particular level to think more sensibly and deduce what goes in the middle. So in question 1, in a class there are 30 students. 10 study cooking, 16 study woodwork, and 12 study neither subject. We need to draw a Venn diagram to represent this information. So let's go ahead and do that. The big issue students have with this is that they think there are too many people to fit in the Venn diagram. What we need to consider though is the intersection, and these people are represented in both of the sets. In this particular case, the sets here are going to be cooking and woodwork. So let's go ahead and do that. So what I'm going to do is put C here and W here, cooking and woodwork. We have 30 students in total. 12 study neither subject. They go on the outside. Now if we just consider we've got 30 students to fit in here. 30 minus 12 is equal to 18. So across these 3 sections, this section, this section and this section, we've got space for 18 people. If we look though, it looks we've got 10 doing cooking and we've got 16 doing woodwork. Now 10 plus 16 is equal to 26. But we only have 18 spaces. What we do here is we do the 26 minus the 18. That gives us 8. 8 goes in the middle because these are the people who are counted in both cooking and woodwork. So they're not separate people, they're just doing both. So all I've done is found out what we've got left in terms of how many we can fill in here, given that 12 are already on the outside. That's 18. It looks like we got 26, but some of these are being counted in both. So 10 study cooking. Well, 8's in the middle, so we can put our 2 here. We've got now 16 study woodwork, well 8's in the middle, and we put the other 8 just here. Does this add up to 30? Well, 2 plus 8 is 10, plus 8 is 18, and then we got 30. So these are what we call the intersection problems, where we're finding that middle, and these are slightly harder. So, drawn a Venn diagram, and we're asked in part B to write down how many students did both cooking and woodwork. Cooking and woodwork is the middle, the intersection, and that's 8. Find out how many students did only cooking. Only cooking is this part right here, which is going to be 2. So as you can see, slight bit more work, but fairly logical. Okay, question 2. At a toy factory, they make a range of toys. Some toys are fluffy and some toys are pink. Out of the 50 toys sampled, 18 were neither fluffy nor pink, 24 were pink and 17 were fluffy. In part A, we need to draw a Venn diagram to represent this information. So again, we've got an intersection to find. We need to find the middle, and we need to do a bit more work than we did in task 2, the previous task. So let's go ahead and do that. Let's just make that a touch smaller. It'll look something give or take like that. Not brilliant, gives us some idea. So what we'll have then is just here, we've got now pink and fluffy. So if I just put fluffy there, let's try and squeeze that on. You could just put F, and we can put pink just here. So we have 50 toys. So what we've got here, 18 were neither fluffy nor pink. 18 goes on the outside, so I'm going to put that there. Okay, let's just consider then. What we've got is 50 minus the 18. 50 minus 18 is 32. So all we've got left now are 32 spaces for these 3 sections. If we just read this now, we've got 24 were pink and we've got 17 were fluffy. Well, 24 plus 17 is equal to 41. So it looks like I've got to fit 41 people into 32 spaces. But remember, we've got these people in the middle who have doubled up and are doing both. So 41 minus 32, well, that is going to give us 9. Just consider that. That's our 9. These are the people that do both. So 9 is in the middle. Now, in this particular case, this is the toys that are both fluffy and pink. So, in this particular case, we've just got toys rather than people. So if we look at this now, we've got 24 were pink and 17 were fluffy. So let's start here. 17 subtract 9 is 8. 24 subtract 9 is going to be 15. So let's just check this adds up to 50. That's 8, 17, 32, 50. Yes, it does. So all I've done is found the middle, and they are the people that are being represented twice, essentially, fluffy and pink. So, in part B, we're asked to find out how many toys were both fluffy and pink. Fluffy and pink is the middle, the intersection, and that is 9. In part C, we need to write down how many toys were pink but not fluffy. Pink but not fluffy is 15. That's this part right here. And then in part D, one toy is chosen at random. Find the probability that the toy is fluffy but not pink. Well, fluffy but not pink is the 8, and we can see that that is going to be 8 out of the 50. Again, we could simplify this if we wanted by halving it and writing 4/25. Either way round, that is the correct probability. Let's do the last one. So what we've got then is this last one. So if I just draw the Venn diagram, we can set this up. So let's read it. 90 people in a social club. 48 of them play darts, only half as many play cards, and 37 play neither. In part A, we need to find out how many people play cards only, and in part B, find out how many people play either darts or neither game. So slightly harder this one, but we'll have a go at it and then go from there. I'm avoiding using any particular formulae that you might have seen in set notation. So what we're going to do is just use basic logic to do this. So what we've got then is darts and cards. So 90 people in a social club, 48 play darts. We've got 24 that play cards and 37 that play neither. 37 is on the outside. So 90 minus 37 is going to give us a total of 53. So if we consider there are 48 playing darts, we've got now half as many play cards. Well, half as many of 48 is 24, and that is going to give us 72. So it looks like we got 72 people to fit into 53 spaces. So we do 72 minus 53, which is going to give me 19. 19 goes in the middle. They are the people who play darts and cards. So darts only. Well, if we think 48 play darts, so this must be 29. 20 and 10 is 30, 9 and 9, 18, add it up, 48. This one right here, there are 24 that play cards, therefore 19 in the middle and 5 just here. Okay, so we've done that. Find out how many people play cards only. The answer is 5. Cards only, 5. In part B, we're asked to find out how many people play either darts only or neither game. Darts only is this part and neither game is this part. So if we simply add those together, we're going to get 29 and 37, which is going to give me a total of 66. So 66 play neither game or darts only. Again, as you do this later on, the more and more you'll use formulae to solve these and use particularly different approaches. The whole pitch of this video is at a very basic level to solve using 2 ellipses in a Venn diagram. As stated, some questions have 3 ellipses. I might do a video on those, but essentially it's the same thing. So there we go, using Venn diagrams to solve problems.